Hello everybody and welcome back. We're looking now at question number 11 on our 2016 grade 7 Gauss paper. The diagram shown contains octagons and squares only. So this particular picture over here, the ratio of the number of octagons to the number of squares is. Now, if it were something bigger, much bigger, or perhaps infinite in size, something like that, we might have to do some sort of work like saying, well, around each square there's 1, 2, 3, 4 octagons, and around each octagon there's 1, 2, 3, 4 squares. It's something like that. Okay, and so if this were, an infinite tiling, it would be a ratio of 1 to 2, or sorry, 1 to 1. But we've got sort of a very finite shape here, a finite list, and we could just count them all out. Okay. There's not really a whole lot to say. I suppose I could draw the picture, just because I do like having things written down. And it's almost like the squares just sort of pop out in the empty spaces between our octagons. Now it's 5 octagons across, and so in between each of those we're going to get squares, which led a student I was talking to recently who had tried this contest. He concluded that it was a ratio of 5 to 4, because if I look at the first row, there's 5 octagons, and then below that's 4 squares, and then the next row it's 5 octagons and then 4 squares. And that's nearly the correct thing. I mean, he is noticing a pattern without actually counting everything up. But the problem is, when he was looking at that, just in case somebody else was thinking that, because I think 5 to 4 is one of the options. But the problem with that is the bottom row has 5 octagons, but doesn't correspondingly have 4 squares below it. It has 4 squares above it, but that would be counted by the row of octagons above that. And there we go. I think I've blabbered enough to have our pattern done here. But there are shortcuts to this. For example, there's 1, 2, 3, 4, 5 octagons, and there's 5 in each row. So if you wanted to just say, well, there's 4 rows of 5 octagons each, you can very quickly add this up and say, well, there's just 20 octagons. Similarly, there's 4 squares, and then there's 1, 2, 3 rows. So there's 3 rows of 4 squares. Very quick to add them up. There's 12 squares. So we want octagons to squares. That's 20 to 12. And that's none of the options. But if we divide by 4 on both sides, the ratio stays the same, but we get 2 new numbers, 5 to 3. And that is one of the options. So our answer is E. Okay. And there we go. So that's question 11 done. On we go to question number 12.